Hello, this is Bruce Winker, President of High Power Optics. This is video number 3 on rail and ring mount inspection in my video series on advanced rifle scope installation. Video number 1 in this series gives an introduction to me and the rifle scope installation goals and methods discussed in this series. This video on inspection of rail linearity and two-piece mount alignment is the foundation for the rest of the installation. This quick inspection takes less than 10 minutes, and doing it before installing the rings allows me to address issues that will only cause problems later on. The purpose of this inspection is to determine if the Picatinny rail is bent or twisted, or if two-piece mounts are misaligned. If either problem exists, I discuss what to do about it. I found that it's essential to minimize scope tube stress because lens assemblies are mounted and are located inside the scope tube. These lens assemblies make contact with the inside surface of the tube and turret housing at multiple points. They provide adjustment of optical zoom and image focus, also known as parallax. The stress-free movement of the internal erector tube is required for reliable windage and elevation adjustments. I minimize scope tube stress by ensuring that the two rings are coaxial and have adequate contact area between the ring and scope tube. Good contact area also improves ring grip, which prevents the scope from slipping. Picatinny rails have become a very common option for installing a rifle scope. Unfortunately, improperly installed rails are also very common. Here I inspect the rail first for twist deformation and then for bend. Either of these distortions can cause the two rings mounted to the rail to be misaligned. The scope tube is machined to be a straight cylinder. If the rings aren't coaxial, they will impart stress on the straight scope tube. This diagram illustrates the problem with rings that aren't coaxial. Also, the scope tube can be dented and scratched at the stress points. The tools that I use to do these inspections include 2 straight steel rulers, 12 to 18 inches long. I confirm that the edges are straight by placing the 2 rulers together and looking for large gaps. A fine ruler or a digital caliper, which is what I prefer. 2 mil and 4 mil thickness gauges. Steel gauges are preferred, but I can also make a 4 mil feeler gauge from Scotch tape as shown. Here I fold a piece of Scotch brand tape and then cut a narrow tongue at the tip. This rifle is an FN SPR bolt-action rifle chambered in .308 Winchester. It has a factory-installed steel Picatinny rail. The muzzle has been threaded by a gunsmith, but the receiver hasn't been modified in any way. Because it is a high-end precision rifle, one would expect the rail to be very straight. In this video, I'll show that this isn't actually the case. I'll also discuss how I deal with a bent or twisted rail. I look for twist by placing one steel ruler laterally across the top of the rail at the front and a second one at the rear. I usually tape the rulers in place to keep them from falling over. The process is the same for two-piece mounts. I place a ruler across the front mount and another across the rear mount. Then I look along the rail axis to inspect if the 2 rulers are parallel. If I can visually detect an angle between the 2 rulers, I measure the angle as shown in this diagram. This measurement is awkward to do accurately unless I take a photo and process the image as I've shown. If the misalignment is obvious, I try to visually estimate the offset at one end of the furthest ruler when the other end is even with the nearest ruler. I calculate an angle in radians by dividing by the length of the furthest ruler. Then I convert radians to MOA. I show an equation for calculating the angle in units of MOA from the measurements in the diagram. In this case, the twist angle is 6.7 MOA. For reasons that will become apparent in a later video, I usually use ring-true tape when installing a rifle scope. It protects the scope from ring marks, prevents the scope from slipping in the rings, and provides a small amount of give when the rings are close but not quite coaxial. This set of rings has been lapped and ring-true tape has been applied. You can learn more about ring-true tape in video number 5. The only time I don't use ring-true tape is when I'm using Burris signature rings because they already have polymer inserts. This table shows the remedial actions that I will take depending on the twist angle that I measure. Negligible twist. That is, the twist angle is smaller than 8 MOA. In this case, I leave the rail installed as is and proceed to install the scope without lapping the rings. Minor twist. That is, the twist angle is between 8 and 16 MOA. If I'm planning to use ring-true tape, I leave the rail installed as is and install the scope without lapping the rings. In this case, ring-true tape is compliant enough to provide good ring grip. If I were not using ring-true tape, however, I would lap the rings before installing the scope. Moderate twist. That is, the twist is more than 16 MOA. In this case, I remove the rail and inspect it. Then I may either replace the rail and/or reinstall the rail using bedding material to remove the twist. Refer to video number 4 on Picatinny rail installation for more details. Next, I inspect the rail for bend by placing a steel ruler along the top. I find it's useful to illuminate the back side of the ruler and look for light peeking through where the rail and ruler meet. This light leakage is easier to see visually than it is to show in a photograph. In this photo, I can see one area on the rail that leaks more light than other areas. Then I try to push the 2mm and 4mm gauges into any gaps that I observed. In this case, a 4mm gauge fits loosely in a gap at the front of the rail, and a 2mm gauge fits in the middle of the rail. When I have two-piece ring mounts like these, the inspection process is the same, except now I place the ruler along both mounts and check for gaps along the side and top of the mounts. In this example of a cylindrical receiver on the Steyr rifle, I can fit a 4mm gauge in the gap on the top surface on both mounts. This table shows the remedial actions that I will take depending on the gaps that I measure. Negligible deformation in the rail or misalignment in the two-piece mounts. That is, a 2mm gauge doesn't fit between the rail and the ruler. In this case, I use the rail as is and proceed to install the scope. Minor bend or misalignment. That is, a 4mm gauge doesn't fit between the rail and the ruler, but a 2mm gauge does fit. In this case, ring true tape is compliant enough to provide good ring grip. If I were not using ring true tape, however, I would lap the rings before installing the scope. Lapping is discussed briefly in video number 5 on ring true tape installation. Moderate bend or misalignment. That is, a 4mm gauge just fits between the rail and the ruler. Ring true tape is not thick enough to accommodate such a large ring misalignment. In this case, I always lap the rings before installing the scope. Large bend or misalignment. That is, the rail is so curved that a 4mm gauge fits loosely in the gap. I could simply lap the rings, but such a large misalignment between the rings would require a lot of lapping to correct. Instead, I usually remove the rail to inspect it. Then I may replace the rail and/or reinstall it using a bedding material to improve the rail straightness. This is the case with the FN rifle I inspected in this video. If I observe minor twist and bend, the combined effects could make lapping the rings not viable. The decision to remove and reinstall the rail versus just lap the rings is a judgment call. Either way, something should be done to prevent a significant ring misalignment. After reinstalling the rail or bases, I will measure the twist and bend again. I recommend using ring true tape when installing a scope. You can buy ring true tape from High Power Optics. I'll leave a link in the description below. This concludes this video in the series. For more information on rifle scopes and their use, see my tutorial by clicking on the link below. Please hit the like button and feel free to leave questions. I will respond shortly. For notice of my future video releases, hit the subscribe button below and then the bell notification button.